Okay, here is warm-up number 8R. All right. We're going to find the first 5 terms of this, this sequence. We're actually given a sub 1, so that's nice. We got one for free. We actually need that first term here because if I asked you for the first 5 terms like this, well, you could plug in a 1 for n, but then you'd have 1 minus 1, so you get a sub 0. And we don't know what a sub 0 is. Or if I plugged in 2, I get 2 minus 1 there, which would be a sub 1. And I don't know what a sub 1 is. Okay, but now that I do know what a sub 1 is, when I'm finding that second term, let's try this out. Okay, so I've got 3 times a sub 1 plus 5. And a sub 1, I already know that's 4. So I've got 3 times 4 plus 5, okay? Okay, and then that 12 plus 5 is going to be 17. So here is my second term, okay? Got the first one and the second one so far, and I need to find 3, 4, and 5, okay? So a little shortcut. When you have a sub n minus 1, this is going to turn out to just be the previous term. This is called a recursive sequence, which just means it's built on the previous term, and a lot of times you're going to see a sub n minus 1. So you notice when I plugged in a 2, this simplified to a sub 1, right? So it was 3 times my previous term plus 5. So that is just telling me, hey, it's going to be 3 times my previous term plus 5 every time. So I like to just kind of build it out like this. Okay, and it's kind of a chain reaction, so I need to plug in my previous term, which is 17 here. Okay, and then I've got 3 times 17 plus 5 is going to come out to 56. Okay, and now that I have the third term, I plug that in this position. 3 times 56 plus 5 is going to be 173. Then the 173 goes here. That's now my previous term. So 3 times 173, adding 5 to that puts me at 524. Okay. All right. So next up, this says evaluate this geometric series. Okay. So if you remember the shortcut, you can actually figure out what the first term and the ratio are really quickly just by looking at this. But we're going to need this formula. It's going to be a sub 1, my first term, times 1 minus the ratio to the n. N is the term number, over 1 minus the ratio, okay? That's what I'm going to be plugging into, okay? So I'm going to have 25 terms here because I'm plugging all the integers in from 1 to 25 in for k. So I'm going to start with 1, end with 25. That means there's going to be 25 of these, okay? Now, the first term, you can build the first term pretty quickly by plugging in a 1 for k. So let's go ahead and do that. Okay, and then I'm going to do my work above here just to save space. Okay, so negative 2 to the 0th equals 1. So my first term is just going to be 3, okay? Now, the shortcut that I was talking about, this is going to be the first term. That only works, though, when you have a k equals 1 or whatever variable equals 1 at the bottom. You're starting by plugging in a 1. And then you also have to have an exponent that looks like this, k minus 1 or whatever variable minus 1, okay? And then the ratio, so to find the ratio, that's what we're multiplying by to get from term to term. So let's find the second term in this. So this second term would be 3 times negative 2, and I'm going to plug in a 2 there. Okay, and this is going to go on, but I'm not going to build the other terms. So then I've got, let's see, 3 negative 2 to the first. So it's going to be negative 6. Okay, so my first term then, here, let me do this. My first term was 3. My next term is negative 6. And it goes on from there. So I'm thinking, what am I multiplying by to get from term to term? Well, you'd be multiplying by -2. So the ratio is -2, which is this. Okay, so again, you can use that shortcut as long as you got these characteristics, if you got it in that format. All right, so my ratio, I'm got 1 minus -2, and 1 minus -2 down there as well. But the one on top, the -2 on top, I'm going to raise that to the n, which would be 25. Okay, so it's really important. You can take the bottom of this and simplify this. This would be 3 because it's 1 plus 2, right? But you can't do that in the numerator because the -2 is raised to the 25th, and you have to do that exponent before you do the subtraction. Okay, so I'm going to do most of this on my calculator. I'm starting with the part I circled there, and it's also really important when you raise -2 to the 25th, put it in parentheses just to make sure that your calculator is not doing the exponent first, then multiplying by -1. Okay, so that is my numerator. No, that's not my numerator. That's this part. So I'm going to do 1 minus that. Okay, so I'm going to hit 1 minus, and then instead of typing that whole thing again, I'm just going to hit second and negative to use my last answer. So it's 1 minus my last answer. That function's really handy. Okay, the denominator would be 3. I don't need a calculator for that. So I'm going to be dividing this by 3 and then multiplying it by 3 again. So actually, those are going to cancel each other out, right? I couldn't divide that by 3 and multiply again, but I'm going to end up in the same place. So just using that numerator there. Let's see, let's put in, so it's going to be 33,554,433. Okay. Let's write a sequence in sigma notation. So the first thing I need to figure out is if this is arithmetic or geometric. So in other words, am I adding the same thing to get from term to term? Here I'm not. It's 8, and then it's a lot more than 8 and way more than 8, right? So I'm not adding the same thing, but I am multiplying by 3 every time to get from term to term. So then I know that this is geometric, okay? And that determines which formula I'm going to use, okay? So I want to pull out the specific term formula, what I call the specific term formula, which is going to look like this. So this is going to come into play when I put this in sigma notation, okay? So sigma notation, I'm going to need sigma, uppercase sigma, okay? Easiest way to do this is by putting k equals 1, or you could do it with an n if you wanted, but something equals 1. And on the top, I'm thinking, how many terms do I have? Well, I see 4 here, but wait a second, this goes on forever. So this is an infinitely long sequence, so it just goes on forever. I'm just going to put an infinity symbol up there, okay? Now, this part in here to the right of the sigma is going to be where I use this formula. So I'm just going to use the part that I circled here. My first term is going to be 4, right? This is my first term. I can just see that that's what the first term is. Then the ratio I already figured out was 3, and then that's n minus 1. I'm going to paste that in here, except I want the variables to match up. So I'm going to use a k instead of an n when I write this down here. And there we go. There's sigma notation of this sequence. So you could always test it out. That's the nice thing about these. If you're not sure, or it's a test and not totally sure, well, just try building a couple terms and see if it builds a 4, then a 12, then a 36, and so on. Okay? All right. Next up, we're told this time this is an arithmetic series, and I'm going to find the 23rd term. I've got the 10th term. I've got the 17th term. So since it's arithmetic, this is going to have a difference, a common difference, which means I'm adding the same thing to get from term to term. So I want to find that first. And what I'm going to do is use the formula for a specific term. A lot of times you'll see this written with a sub 1 in the slot, but I'm going to change that to a sub m. And then inside the parentheses, I'm going to have n minus m. So yeah, often it's 1s in those 2 slots, but since I don't know the first term, I changed this. I'm using this this updated version of this formula so that I can use any terms I want. Okay, so I want to find the ratio. What I'm going to do is plug the two known terms in for a sub n and a sub n. You could put the a sub 10 in the first slot if you wanted to, but I'm going to put the a sub 17 in, and I'm going to put the a sub 10 in that second slot, just because I have to subtract in the same order. So those should match up. So I'm going to have 17 minus 10 in here instead of 10 minus 17. Not a big deal, but I was just trying to keep that positive in there. Okay. Once you get that in, then plug in the actual value of these two terms. A sub 17 is 44, a sub 10 is 2. Okay, and hey, 17 minus 10 is 7. And then I'm just solving this for d. So I'm going to subtract 2 from both sides. Okay, I just rewrote that as 7d, and then divide by 7, and your difference then is going to be 6. Okay, so at that point, you could actually just kind of build your way to the 23rd term from here. You just keep adding 6s. But I'm going to do this algebraically, because sometimes you might be asked for like the 900th term, and then I wouldn't want to build a sequence out that far. So, stage 2, I'm going to find a sub 23. I'm going to find the 23rd term here. I'm going to use this same formula. So here, I'll just rewrite it so you can see what I'm plugging it into. Okay, and since I'm finding the 23rd term, I could put a sub 23 in either of these slots, but it's much handier if it's here because then it'll already be isolated. Okay, and then a sub m, I could use either of these terms. Just because I used a sub 10 in that slot on the left side, I'll put a sub 10 in there again because sometimes it confuses people when I choose the other term. Okay, and now the difference I already found was 6. And then I should have 23 minus 10 in the parentheses here. Okay. So I'm going to start simplifying this, but I'm also going to now plug in a sub 10 because I know that equals 2. So a sub 23 equals 2 plus 6 times 13. And hey, we're almost there. We just need to do the multiplication. So 6 times 13 is going to be 78. And then a sub 23 is going to be 80. That is the 23rd term in this arithmetic sequence. If you had a geometric one, you could do it really in a similar kind of way, except you'd use this formula and replace the ones with m's. Okay. All right, that's it for this warm-up, and I'll see you next time.